This morning I'd like to try to educate you on what we've been doing for well over 30 years. My predecessor about 30 years ago, back in the 80s, brought in or introduced SBR latex into our asphalts. We were having problems with cracking. Fortunately in our district we haven't had a lot of rutting problems because we have good aggregates. Cracking's always been a problem. So I'm going to go through a little history. I'm going to show you some roadways and also go through the specifications in case anybody wants to get on board with doing the latex. As we've seen in many presentations, and most of us know, we do have problems with our roads. We're getting cracking, we're getting rutting, we're getting early oxidation, so we get white roads. And our maintenance group is saying, okay, we're crack sealing the first year after placement and we're seal coating 3 years after construction. That's not acceptable, so what can we do? So I introduced latex to them and they bought onto it. We end up with roads that get a lot of cracking like this, so basically when we go to overlay we have problems with more cracking. Just a reiteration also, the wrap and the RAS are causing a lot of this because it's stiffening up the material, the actual hot mix. And we know that we're getting less asphalt in there, as Robert mentioned yesterday, so we're getting brittle mixes. And also, one of the big things we found early on when Andrew Wimsatt was our pavement engineer, that the Hamburg is not indicative of modified asphalts. And even Sharp, when they came out with Super Pave, said, no, we did this on unmodified asphalts. So we're not a big believer of using Hamburg, as I'll show you in a minute. I got these slides from BASF, and I think they're a good indicator or they show you what's actually going on. With SBS products, they mill in the SBS into the asphalt. So this slide is showing that the SBS modifier is inside the actual asphalt droplet itself. So it does perform well, but there is a difference between the SBS and the SBR. Here you can see that the SBR is actually in emulsion form, just like the asphalt is a liquid as well. So how are we trying to combine them? Well, they're actually not combining them. They're using it as a layer to coat the asphalt. And when I saw this slide a few months ago, I thought, this is interesting. One of the things that the latex is doing, in my opinion, is that it's coating the asphalt and it's providing a layer of UV protection. My understanding is that the ultraviolet rays from the sun are one of the key factors in oxidizing the asphalt. So by coating the asphalt with latex, we are putting sunscreen on it basically to keep the oxidation slowed down. And over the years, I'm convinced that this is the method that is keeping our roads black longer. And I've just reiterated this here on these slides. The last item is what I want to focus on next, and this is on the Hamburg. These are recent slides from latex mix that we just had run about a week ago. And you can see that this is pretty severe rutting if you go strictly with the Hamburg. But we have not seen this out on the road. Here's another slide with wrap. You can see there's less, so the wrap is stiffening up the mix. Once again, we're not seeing this out on the road, so we're not big proponents of using Hamburg to predict rutting out on our roadways. A history, we started using latex back in the 80s. My predecessor started doing that, and we were actually adding latex at the hot mix plant. We found out that if you do it at the refinery, it tends to separate and doesn't stay in solution. And then also, my predecessor was adding 3% latex in AC10. AC10 is like a PG58, so we're definitely much stiffer with our 70s and 76s now than we used to be. Of course, we've heard that asphalts have changed over the years and decades. They've been stripping out more of the good stuff. So we actually have blender companies that are coming in and trying to put more good stuff back into our mixes. In the early 2000s, we went with PG Plus specification. Some of the districts were working on that to try and get different asphalts to use in their mixes to help with these different situations that we were having. And then in 2011, our Fort Worth District Maintenance Group came to us and said, what can we do? I recommended latex. The staff bought into that, and we've been doing it since then on our surface mixes. I found this slide when I was putting this presentation together. It's quite interesting that we have different asphalts and different colors of these. And we kind of have fun with this, especially the asphalt concrete side of it. You can see at the top where we have that the very top of the hill is actually concrete pavement. And then as you come down the hill, you get into another white pavement. That's actually hot mix. And so when it gets this color, we actually claim that it's concrete at that point, and the concrete industry loves it. But that doesn't help the asphalt. So we actually end up with different colors, and it doesn't help with the striping. It's hard on the drivers, especially our older drivers, as they get that color change. And so this is what we're not trying to have. This is where we're trying to get to. And as you can see here on the left, we actually have construction, or just post-construction, and then I took some photographs 2 months later. And once again, to try and show that we are getting that early aging of the asphalt, and it's turning white, which is what we don't want. Back in 2005, excuse me, we actually paved a city street, which is one of our state highways, and so we've been trying it off and on. Just some slides here showing you're not going to see any difference in the mix itself. It's a very normal operation. It looks the same. The latex is mixed in there. Sorry, I didn't have any money or any keys to put on this one. I think it's interesting. We've changed from coins on the road to keys and pens, so I'm not sure how that's happened. I guess we're not getting paid enough. Oh, there's the pen, I'm sorry, but that was 2005. You know, the mat looks normal. You wouldn't know that there's latex in it, except every once in a while we would get some latex balls in there. Fines would wrap around it, and we'd have some problems. And then the pneumatic rollers would pick it up if they weren't using an appropriate release agent or something to coat the tires. Recently, we've been going out and looking at our pavements. This project was done 3 years ago. It's on Interstate Highway 35W south of Fort Worth. And you know, we've gone through 7-8 miles of it and looked. What you're not seeing here is cracking. Now, there is some oxidation of the asphalt. It's not nice and black as when it first went down, but we're not seeing cracking. And that's what we're trying to avoid. The latex is not a preventive measure. It's a retardation process. We're trying to slow it down. We're trying to get our crack sealing and our seal coat program farther into the future, so we're not expending money quickly right after construction. These slides are just showing the condition of the road right now. Yes, there are a few cracks, but they're very minor, and we're not to the point of actually crack sealing them yet. You know, 3 years later, I think this is a success. This is good-looking pavement. We don't have to worry about this roadway. This is a project we did 7 years ago. There was a small town in our district that had come to our district engineer and said, hey, can we get some help rebuilding this road? This is going into the Naval Air Station in Fort Worth. And what's interesting is that when we actually went out to overlay it, we found that there was wrinkled tin joints. And I had heard about it, but I'd never seen any before. So it was very interesting to look at that. That's what they used. It was jointed pavement, but they used the wrinkled tin in between to separate those concrete slabs. A lot of cracking. Anytime you would try and pave this roadway, you'd get a lot of cracking. This is actually 7 years after we paved it. And what we did on this project was we did SBR latex, and we did the other half of the project with crumb rubber. Can you tell which one is which? I can't. I never remember, so I go back to the research report and try and find out. You can also see cracks. These are the transverse ones with the wrinkled tin. Once again, we didn't prevent it, but we have retarded it. One other interesting point is we laid this in the summer. The next year we came back and looked at it in the winter, and we had some cracks develop. They were very minor. We came back the next summer, and the cracks were gone. This was a very high asphalt type F mix. What was interesting is that the asphalt was softening during the summer in the heat and covering or minimizing the cracks again. It's like, wow, this is really good. So we have high asphalt, and we have latex, we have crumb rubber as our modifiers. Something's going on here. We had the good fortune of having TTI look at this roadway for 5 years. And here's what they came up with after that time. They were showing the latex and the GTR, ground tire rubber. And yes, we have cracks, but after 5 years, it's definitely performing well. There's no reason to go out there and work on that structure. So the city, even though it's theirs totally, there's no plans to go out and actually work on this road and provide maintenance. Here's another road that we just did a couple of months ago. I was actually out on this job, and the mix looks great. It was black. You could not see the latex in it. It was very homogeneous. We have a good-looking road, and we expect it to last a very long time. One of the things I want to do is, because I'm trying to educate with this presentation, I want to show you what we're doing with our specifications, because that's critical to getting this into the mix and getting long-lasting pavement. So I want to cover the major items that go into our plans, our PS&E, to make sure that the contractors are doing this per our specification or our needs. I've taken the specifications, some of the other items, and I've listed in green the items that I think are important. So I'm not going to read these to you this morning, just the green part. One of the things you need to do with the injection of latex is get it into the asphalt in line before it goes into the blender. And because asphalt is an emulsion with water, it will foam when it hits 300-degree asphalt. That's not good, especially if it's in the drum. So we bring it back prior to the drum, inject it in the asphalt line, put it into a mixer, and let it do its foaming and its action there to try and get that homogeneous mix. We are also requiring a PG 70 minus 22, and what we require of the hot mix producer is that you meet that grade. But we require 64 minus 22 or an AC 10, add the latex that's needed to bump it up to the PG 70 grade. This is showing on your left a typical mixer. I pulled this off of the internet. We've been out to all the hot mix plants that are servicing our district producing hot mix, and there is a variety of static mixers out there. We also have one company that has come to us and said, we have a mechanical blender. We'd like you to require it to be used. We said, no, we feel like we're getting the mixing done with this process, so we're allowing the producers to decide how they're going to meet our PG 70 22 grade. On your right, I have circled in yellow the sampling port. It's critical that proper sampling is done on this product. We want to have a sampling port prior to the static mixer so you can get the asphalt coming from the tank to test it. You also want to sample after the latex is injected and mixed in because you want to know if it's going to meet the PG70 grade. We have found out in our trips to the plants that proper sampling has not been done. When that's not done by the producer, they run the risk of failing asphalt. So what do we do with that? Well, we have to enforce it to try and make sure they're getting enough latex in there per the design and it's becoming homogeneous. If it's not homogeneous, we'll get latex balls and other issues as well. And then also we need metering equipment. It has to be metered and tied into the plant so we know that we're getting the proper amount of latex into the asphalt binder itself. One of the things we were not doing was getting special spec 3001 into our plans. So I've made a concerted effort to get with our designers, educate them, remind them, and even when I'm reviewing the plans, tell them they need to get this in there because it tells the contractor that they have to come up with the design and we will do daily production sampling. That's one of the things we have not been focusing on, but we know that the producers are saying they're getting failing asphalt. Well, let's start looking at your sampling. Let's look at your injection process. Let's go ahead and get daily samples so we can get a bigger database to see where the issues are if they really are occurring. And special spec 3001 gives us a nice checklist of things that we can look for and that the hot mix producer needs to do. I guess I got ahead of myself. This is where we need to go ahead and make sure that we're sampling. If you run into problems, if you're not getting the PG70 minus 22 grade, I highly recommend that you draw a sample of your base asphalt prior to the mixer, you draw it after, and also get a sample of your latex. We know that all these materials can be compromised. We need to be checking them as part of our forensics investigation to find out where the issue is, or hopefully not issues, but one issue, and try and help the producers be able to meet the criteria. Looking at general notes, these are things that we've put into our plans that help. We need to make sure we're telling them which grade of asphalt to use, and so the A is highlighted here. And then in the next sentence it says to provide the PG asphalt. And in all of our specifications, not only do our TxDOT people, but our contract partners also interpret our specs differently. So in this case, I've rewritten our general note to try and clarify that first of all, we're telling them what grade we want, and second of all, how you're going to go about modifying that grade that we are requiring. So once again, I have a PG64 minus 22 and an AC10 that can be modified with the SPR latex. It has to be done at the plant, at the hot mix plant. We do want the certification or the mill cert on the asphalt, the base asphalt that's coming to the plant. The amount that goes in is up to the producer. They need to have their labs run the base asphalt and determine how much latex needs to go in to meet our PG70 minus 22. We are not allowing grade substitution. We are also eliminating RAP and RAS right now, so we're staying with virgin material. And our effort is to try and make sure that we're getting good, long-lasting performing mixes. So we're taking out variables. I do have a goal of trying to get RAP back in eventually, and possibly RAS, but that's for the future. We'll have to see how our pavements perform. And then also, in the last note, we are waiving, in most of our area offices, we are waiving the requirement for the Hamburg. As I showed you the photographs earlier, it's just not a good predictor of modified asphalts, and we have not seen that rutting out on the road. We also make sure that we get the proper bid codes in, not only for your surface, but for your level up. And these are already in the system. Austin has set that up. And so your designer just needs to make sure they pull in the proper note that has the latex additive in there. You need to make sure SS 3001 is in your specification, your spec list. And I didn't put it on here, but also on your plan sheets, your typical sections and your summary sheets. Make sure you put in parentheses or somehow indicate that you want latex additive. We found out that when we did not do all of these things, the producers, the contractors would like to come back to us and nitpick the item and say, well, you don't have it here, we don't have to do it. So we think we've covered all the aspects now, all of our bases, so to speak, and make sure that everybody thoroughly understands from the beginning we're looking for latex in our surface mixes and our level ups. Technical considerations. Our department's #1 goal is safety. Okay, are we giving the traveling public a safe road? If we can keep the asphalt dark longer, there's a good contrast with the striping. So those of us getting older, we're able to better see at night. Even in the daytime, I've seen a lot of our striping disappear in the daytime, especially in the sun, and also during bad weather. So for me, as my eyes age, this helps me. We're trying to build roads or lay down mixes that last 15 to 20 years. Our previous history is 25 years. Why can't we continue that success? I like change, but only if it's going to make things better. I don't do change just for change. So we're back to trying to get successful roads again, and I don't have any question that we can get 25 years out of these with little to no maintenance. Also, this gets the producers down to 1 tank of asphalt instead of 2 or 3. They can have 1 grade of PG64 in their tank, and they can make a 70 or 76 for their clients. It can also be used in warm mix. We like to use warm mix when we have heavily crack sealed pavements. We lower the temperature and we have less compaction, and that the crack sealant doesn't come back through and crack our pavements. And then also we are trying to keep our pavements more flexible, so we're looking at softening our asphalt below 64 to try and soften things up. And finally, in conclusion, we're striving for high quality. We're trying to provide excellence on our roadways. And once again, why reject 25 years of history with latex? We've proven it. So let's continue to try and do that. And once again, just to summarize, we are injecting SBR latex at the plants, not at the refinery. Although we have several blending companies in Fort Worth, Dallas area that are talking to us now about possibly doing that. We have switched from the TGC to the SGC to try and get more asphalt in. I've continued to talk to Robert and others about that. And we've also basically waived the Hamburg. So that's my presentation on how we are using SBR latex in the Fort Worth district. Do we have any questions? Yes, sir. I'm sorry? What percentage of asphalt are going into the designs? It's just the standard mixed design. And so if you're doing a type D or a type C, if the design comes out to 5% optimum, that's what they're shooting for at the plant. It goes JMF1, JMF2. The amount of latex that's going in is generally about 1.5 to 2.5%. It's totally based upon the base asphalt as to how much goes in. We even have some asphalt coming from refineries. It doesn't matter how much latex we put in, it never raises the grade. And so the producers are quickly finding out which asphalts will not allow that raise in grade. So it's totally done in the design process. The question is, are we running the overlay tester on these mixes? Not yet, but thanks, Tom, for giving me another project to work on. That's good. We need to. We need to. Thank you. Yes, sir. Is there any effect on the workability or the VMA? To my knowledge, no. As I showed in those earlier slides, it's a regular hot mix job. There's very little latex in there. I guess when we actually got into 3 to 4% latex, it would become more sticky, and so they had to be quicker with it, keep it heated more, use release agents on their equipment to try and provide that barrier from sticking. But we're in the 1.5 to 2% range right now, and they haven't seen an issue with that.